So before coming to topic, I think I would probably just kick off introducing ourselves. Ashutosh already mentioned that this is the first time Prague is presenting. So I work closely with the delivery in Prague with Axion, and John works, who is co-presenter with me. He works with the product. We both work for cybersecurity provider Veracode. So, so coming to the agenda today, I think you can read, but I was looking at the poll earlier. Yeah, what are going to be the next 10 big things? What was the second on the list? Does anyone remember? The first one on the list, everybody remembers, Gen AI. What was the second on the list? Yes, it was cybersecurity with 19%. I just remember it. We can go back and check, by the way. And yesterday, Samir also mentioning that from investors' perspective, cybersecurity is going to be the focus areas for the organizations. And this is what we are going to cover today. So the state of software security, DevSecOps, AI and machine learning influence in cybersecurity. So we all know Gen AI and machine learning has gone beyond just the buzzwords. Organizations now widely adopting, everyone is using in their applications. But at the same time, it has also opened the doors for attackers to attack. Now, can anyone say, or I welcome any views, why cybersecurity is suddenly becoming important? Why? From last 2 years, probably we are hearing cyber resilience. Any views on this? Of course, I mean, the first reason is we are being attacked, companies being attacked by the cyber attacks. But what is the main reason? Anyone? We have seen in recent years that the growth, the pace of software development has been immense. However, the same pace was not maintained within the security development. So the security is still catching up. Yeah? And that is the fundamental thing why cybersecurity is becoming more important. So I think Paul mentioned me, I think earlier, that I think you mentioned innovate before you have to. Yeah? So cybersecurity is a good example now where we have to focus the area. So you see that more than 80% of the organizations, they cited ransomware attacks, all type of data breaches. They are very high risk. But 70% of them have said that they're not really sure that if they are fully prepared for this. I will back this up with the stats, by the way. So looking ahead, putting the right security strategies, using the AI and ML to fight with AI and ML has becoming the priority for the organizations. Now, DevSecOps, I will just introduce you here with one liner that it's a natural evolution of DevOps where security is at the center of your SDLC. And I'll leave you with that. We'll just cover it up in a bit. Now, cyber attacks are common and costly. Can anyone name few security threats? Some cyber attacks? Anyone? Ransomware, okay. Any more? I didn't quite hear that, sorry. Yes, cross-site scripting, yeah. Yeah, there are many. Phishing, identity fraud, identity theft, credit card fraud. You can see. So you see that most of the organizations, now ignore that error because I don't have the numbers on those orange bars, okay? But if you sum that up, so they are around 40. So if you sum, so more than 80% of the organizations, they are either extremely or very much concerned about the ransomware attacks. And that's why I was mentioning earlier that either they have one of the top 3 priorities or one of their most important priorities to have these security strategies in place. You have seen, now this is as per the Cisco study, we have seen the immense growth in the DDoS attacks. And no surprise, many organizations have been putting the bounty programs, which encourages developer to find out the defect and reward them. Now, this makes us think about what's the current state of the software security. So if you see Java and .NET, they are clearly the choice right now for the application development. Yeah, JavaScript, Python, they are slightly behind. And before that, I would probably like to define what flaws is, what flaw actually is. Because this flaw is behind all these cyber attacks. So flaw is nothing but the implementation defect, which can lead to a vulnerability, which can cause an exploitable condition within your code, which allows the attacker to attack. Now, there are 2 big organizations, OWASP and CWE, Open Web Application Security Project and Common Weakness Enumeration, who help developers or organizations to identify the top 10 and top 25 security threats, which are the prime base for the cybersecurity providers. And that's how they are building their tools. Now you see that more than 75% of these applications, so Java and .NET, they have either some sort of security flaws. And to move further, not only they have only some security flaws, they have 20% chance that they have a critical security flaw, which is exploitable. So this is as per the Veracode State of Security report, which is an interesting diagram. See, when the application is at the initial phase, you see, and the scans are performed first to identify these vulnerabilities. They are initially more than 30%, and they slightly come down as everyone works at the beginning. And for first year or 1.5 years, which I will call it as honeymoon phase of the applications, where you are still limited with the security flaws. The application doesn't have many security flaws. But as we grow, as the application becomes more mature, we think that it becomes more mature, but at the same time, there is a chance of having new flaws in that application is growing. And you see that's approximately 35%. So number of applications with the new flaws increases to approximately 35% for next 4.5 years. So what is the problem? The problem is when you don't remediate those flaws. When organizations don't remediate and they build. Everybody talked about technical debt. I have heard like at least 5 times technical debt. Now we are talking about security debt, which is nothing but when you don't remediate those flaws, you end up in the security debt, and the stats tell, okay, 71% organizations have the security debt, but the right one is the key. They have 45% of the companies, they have the critical security debt. What could be causes? The causes could be, I listed a couple of them, I'm not going to read, but you can see that software dependencies, neglecting the modernization, inadequate security testing. So the traditional QA testing is not sufficient. And that's why application security testing remains at the focus when it comes to cybersecurity. Has anybody heard SAST and DAST before? Raise your hand. Just raise your hand. SAST and DAST. Okay. Okay. 15, maybe probably 20%. Okay. So I'll describe in a bit. But you see that earlier you identify those defects, lower the remediation cost. So we discussed about the problem. Now one of the potential mitigation approach which we are discussing is the DevSecOps. I already mentioned that you have security at the center of your SDLC. But with DevSecOps, you see the comparison with the traditional quality model. Your shift left model gives the attention to the quality and security right from the beginning. So what are some of these DevSecOps tools which we are now using on day-to-day basis in Veracode, and also the customers use this. So we are pretty much immersed into this. And so you would probably ask, what is innovation? Well, we are working on these tools to make it more innovative, have it automated inside, see the opportunities. Interactive security testing is pretty new. I think SAST and DAST, I will just introduce. So SAST is your static application security testing, which is nothing but running the code scans at the beginning. Your dynamic application testing is outside in. So SAST is inside out, where you identify your code and scan your code, while the dynamic is outside in. You have the software composition analysis, where your open source components are also analyzed. And these tools are becoming now more mature, more innovative in a way, not only identifying the vulnerabilities, but also suggesting the fixes to them, which my colleague John will also cover little late. So we took a case study. Now we talked about, okay, what exactly cybersecurity is. Now let's look at one case study. Yeah, because everyone from the higher up in the organization would be interested in, okay, what's the saving? How it's going to benefit. So if you look at, for a complex product which has 200,000 lines of code, we found there are approximately 8 bugs for 1,000 line of codes. And by that, you see, for your same product, you have 1,600 bugs. And considering the cost to fix your bug, you are spending 2.4 million only on the bug fixing. Now, if you see the total cost for engineers, so if you have an engineering team of 40, so you are spending 40% of the team throughout the year only for the bug fixing. Now, how this can be avoided? Yes, so have the SaaS model in place. So we had the SaaS model in place, which was still not automatically integrated, by the way, back that time. Now it. And you see that with 20% of the effectiveness, the defect reduction from SaaS, you are still saving quite a significant bit. The numbers on the right are for reference to tell that testing phase where the bug is found and the cost of the bug, it increases more and more. You delay the testing. Not just from the cost perspective, but also from the resources perspective. So you have, if you identify these vulnerabilities earlier, you have very less exposed to your colleagues in the organization. And that's how you are saving these resources. Now, this is only about SAST. There are DAS, SCA, which are also giving the enough and significant benefits. Okay, now probably I'll hand over to my colleague John to talk about the further influence of AI and ML.
All right. Thank you, Nilesh. I am the last speaker in the last talk of the day. And I got to say, right now, I feel just drunk with power I have over the schedule for the evening. But I'm going to try to be a good steward with that time. And we've seen a lot of amazing insights about innovation. I'm also going to try to live up to the standard that has been set. Nilesh has introduced a couple of AppSec concepts, and I want to look at how this fit into the SDLC. So we have got here, we have an SCA and SAST scans that are kicked off in the code build. Just a quick reminder, when we talk about SCA, that is software composition analysis, and that is going to look at your third-party libraries. That is particularly sticky because it could be that you're using something open source that is perfectly fine, doesn't have any known vulnerabilities, but it is depending on another library that does have some vulnerabilities, or it's depending on a library that's depending on another library that has some vulnerabilities. So getting to the bottom of that is tough sometimes. We've got SAST that's also running our static application security testing, and that is looking at the code that we have created and ensuring that we're not introducing any flaws. So following that, we've got a deploy step, and then we get into testing, and that's where our DAST happens. That's dynamic application security testing, and you can think of that as really sophisticated, automated penetration test. So this is where we are today in terms of integration into the SDLC. But what if we want to take that further? What if we want to do better with ensuring security in the applications that we're building? What does better even look like in this context? What does better mean? In AppSec, a lot of this stuff can easily be automated. It's a common practice to kick off your SAST scan when you check something into the repo and you open a merge request and boom, there it goes. Where it gets sticky though is when we encounter a flaw, when we have something that we need to take care of. Our SAST may come up and say, hey, you've just checked in, I don't know, something with a SQL injection flaw. And then it'll give us maybe the line, and we need to go back and we need to figure out what's wrong and how to fix that. So remediation is actually the sticky part. So when we think about where do we go next with this? How do we make this better? Automated remediation opportunities are kind of where we're thinking. And I think, as Nilesh mentioned, he and I work with one of our partners, Veracode, who are working in AppSec. And they've already started to work on this. They have a product that is called Veracode Fix. And what Fix does is an extension of SAST. And when you have your SAST results come back, it doesn't just tell you, hey, you've got this flaw here, go check out this line and figure out how to fix this. It actually gives you some remediation opportunities. So it says, hey, here's where the problem is. You could fix it in these couple of ways. If you want to do that, then tell me now, and it will actually go ahead and make those changes for you. So they are working on, they're not working on, they have done these first steps towards automated remediation. That's pretty hard to do. Just really quickly, has anybody ever used specifically like a chat bot, like ChatGPT or Gemini or something like that, to generate some code? You've gone in and you've created a prompt. Just raise your hands if you've done that. Okay, that's a fair number of people. I can keep the hands up for a minute, and I want you to keep your hands up if after you generated that code, you thought to yourself, hot damn, that is some world-class code. All right, I see a couple of people who are hesitant. That makes me think, like, you don't really work in code or you're awesome at like prompt engineering, because generally it's hit and miss. Sometimes it's fine, and sometimes it's not super trustworthy. And so getting to a place where we can trust what we're getting, that takes some work. Nilesh had also mentioned machine learning earlier in his segment, and this is a prime example of that. So when we apply machine learning to historical policy violations, code review scans, like threat detection, that kind of stuff, we end up with a good idea of how to detect the patterns and habits that lead to security flaws and vulnerabilities. And Veracode does have an advantage here because they've been around for better than 17 years. They've been working in the AppSec space. They got a massive data set, and they've used that to build a really targeted, highly capable model that they've then trained their Gen AI on. So we see some steps that are being taken in that direction, but where else can we go? We've got SAST that's giving us some remediation. But we can easily imagine this, and it's kind of imagination, but it's really the direction that things are generally going, where this is nearly fully automated. We've got a scenario where developer is working and commits some code and opens a merge request. That kicks off that SAST scan that I'd mentioned before. We find a flaw, and we get a list of remediations that are not just possible ways to fix the issue that we're seeing, but also are in the same language, and they also match the coding conventions that we've been set. They match the style that has been set. And the developer can simply make a choice. This is the one that I want to apply, and that is seamlessly integrated back into the code base. Following that SCA scan kicks off, and we can see if there are new vulnerabilities that have been discovered in the libraries that are being employed. We can see if some new libraries have been added, if there are vulnerabilities there, and we can get remediation there as well. We can be told, look, you're using this library or this component that leans on this other one, and you need to swap this out for this one that doesn't have any vulnerabilities present, or you can do these other things to fix that. We choose what we want to do and remediate that, and we move on. That is compiled then, and that is deployed to our environment of choice. And on deploy, we then have a DAST job that is kicked off, and that looks to see if there have been some configuration changes or something that happened in the application since last time that the scan was run, that maybe violates some of the policies that we have set, and then can alert us, look, this change is here, you set a policy that said we don't want anybody to be able to do this thing, you may want to go and do something about that. So we can see this world where everything is shifting very far to the left, and the developer can, just by checking some code in and opening that merge request, can end up in a place where we are very confident in the security of the application because we've done this end-to-end suite of tests. So with all this in mind, it feels like we are on the verge of a fully automated, intelligent, human-free security pipeline. Feels that way, but that would be absolutely wrong. Gen AI isn't ready for us to fully lean on it, and it's not going to be any time in the foreseeable future. As I pointed out earlier, this is a pretty difficult problem to solve. We need experts who are able to choose the right remediation, who can go in and identify, okay, this one is okay, but this one is really going to be optimal for the problem that we are trying to solve here in ensuring that our application is secure. So I'd mentioned Veracode Fix, and I want to take just a moment to look at a quick demo of that. All right, and I expect to see that somewhere.
Yep.
Okay, great. should have audio.
I'm going to
Well,
demo Veracode Fix, our AI-augmented remediation assistant that was built for developers to tackle existing security debt and to help prevent it in the first place. It can be used to tackle existing security debt by using it against currently vulnerable code and patching those addressable findings. It prevents new security debt when it's integrated into the developer's regular workflows, making the solution to flaws available as soon as our static pipeline scanner finds them. I'm going to demo the first use case, working from the perspective of a developer who's been assigned to remediate a flaw in a module of an application, and I'll use Veracode Fix to do that. What we've been looking at and where this tool operates from is the Veracode command line interface. And following configuration, there are just two things we need to run the fix command. We need to have a results file from having run a pipeline scan, and we need to point it to our source. And what that looks like is invoking the Veracode fix command, and we've pointed it here to usercontroller.java in our known vulnerable Verademo app. It's returned a number of addressable findings, and I'm going to go through here and find the one that I've been assigned, which is right here, a CWE 117 on line 237. It's issue ID 1233, and if we take a look here, we'll see that this is redirecting to a view which is called next view. And if we investigate further, we'd see that it's being provided as a redirect to a target. That target comes in as a parameter on the request, which means the user can specify it, and that's why it's flagged as a problem. All right, it's time. And when we're ready for the tool to generate a suggestion, we just enter the issue ID, which was 1233. And it's going to provide up to 5 results, returned in order of the likelihood of solving the problem and successfully compiling upon execution. It's returned a few results, and the first one looks like it's URI encoding the command, so we don't get character returns and line feeds included. I'm going to pick option 1 because it's been suggested as the most likely solution, and I don't see a reason why we should choose the other. What this is going to do in the background is apply the change, back up the original, and save the patch locally so we can look at it and potentially reuse it. Behind the scenes, Veracode looks at the problem in the source code, and not just at the correlated line of problematic code, but the full stack trace, so we can understand how we got there. And it's comparing that to a list of known problems for this particular CWE 117. When it sees one or more matches, it will start to process potential solutions for that specific type of problem. Then, our machine learning model, which utilizes GPT, takes the fix based on Veracode history of remediation best practices. It maps it to your code and then provides it back to you as a patch, which can be quickly applied. Basically, this provides developers with suggested fixes for those issues they're working with and might not know or have time to investigate what the best practice way to approach it was. Thanks for your time and attention. We're looking forward to you experiencing Veracode Fix soon.
okay. So, yeah, it's pretty cool what they're able to do. So that's it. That's how we get from where we are today with cybersecurity, DevSecOps, why that matters, and where we are going with that, what we're trying to achieve. We're going to make faster and more reliable software, deliver higher quality applications with reduced defects, and do it as efficiently as possible. Thank you so much for your time. Nilesh, let's take some questions.
Thanks, Nilesh. Thanks, John. So given the rapidly evolving nature of cyber threats, how can ML models be designed to adapt and respond to new types of attacks not seen during the training phase?
Yeah, so I think this is a good question. John was mentioning that Veracode has 17 years of data set. Yeah? So your data set is key for the ML model. And when these new changes are coming in, the tools on our side, the tools allows to store those results immediately for the next comparison. So we think that And that comparison can be same use. However, each and every organization or tools would probably need to maintain this, and that is the accurate way of, I would say, updating the data set. Unfortunately, OWASP and CWE both have these security threats presented every year. So there is no reduced frequency in that. So yeah, I think good question. We don't have perfect answer to this.
Sure. Can AI find out the vulnerabilities which are not yet defined by OWASP? What would be 3 to 5 inputs to this model?
The answer to the first question is, what is vulnerability? Yeah, that needs to be defined. And with AI, you need a data set. So we have a data set which we compare it against. Results are thrown. And whatever is not matching, it's a new flaw. It's a new vulnerability. We are also storing them, and that is for the manual intervention. That is not for the automated. That is for the manual intervention. So there has to be the manual layer which needs to confirm that as the vulnerability, which is the real practical use case that we have. Yeah.
Thanks, at least for defining how vulnerability can be defined. So how do you keep up with the security when you are using thousands of external packages which have vulnerabilities and keep updating when they find it?
Using the right SCA tool. Yeah, I just mentioned about SCA, software composition analysis. There are plenty of tools available, by the way, in the market. Veracode has good SCA tools as well. And using these SCA tools, they are specifically designed to identify your open source vulnerabilities. So no matter if they are evolving, the SCA tools are capable of handling these open source vulnerabilities. And even the licensing issues. So let's say you're using or you're dependent on some external parties who depend on the licenses. So we need to catch that. And the SCA enables us to catch these licensing issues.
Could you discuss the balance between automated ML-driven security measures and the need for human oversight in DevSecOps?
I think you covered that very well, that so the tools are getting more and more innovative in terms of recommending the fixes. But there still needs to be human intervention there to be able to confirm and then apply those fixes. We are not fully automated yet. So can you repeat that once again? So the balance between the human, as I said,
I think it's looking for the balance. And so the balance there, I think we're not fully leaning on the machine learning or the generative AI results that we're getting back. And it's going to be a while. Like I said in the deck, generative AI is just not at a place that we can fully trust. There are zero hallucinations. There are 0 times that we're going to ask it to fix our SQL injection flaw, and it tells us, okay, it should be blue. And so we need somebody who has that expertise. And for a long time, we're going to need somebody who understands this is what this flaw is and can look at these remediations. So the goal isn't to eliminate the need for that skill set. That skill set is going to stick around for a long time. The goal is to eliminate the friction between the system identifying, yeah, here's a flaw, you didn't pick it up as you were coding, you were in your zone, whatever, and having that remediated. So we're still, those are going to be codependent and coexisting for the foreseeable future. We need somebody who can recognize that, yes, this is definitely the way to do this.
Just to add that, I now recollected. Have you thought what is the con behind this? So we talked about SAS, DAS, SCA. We are able to identify the vulnerabilities and the code patterns. But what about the business logic? Yeah, the business logic can be, it is there, but it is very difficult to catch that business. So I would say that for manual, maintaining that balance, the business logic layer needs to be verified or needs to be there only with the manual intervention.
Last question. Are we using any existing ML model or written your own model?
So this was Veracode Fix. I mean, we are working for Veracode Fix, and Veracode Fix uses the AI, which behind uses the ML model. So yeah, I think you have seen the example of that. And if you're asking me personally, I think yes, I have prototyped one model, but not using the fix, but using. Has anyone heard of Amazon Code Guru? Code Guru, yeah. So Code Guru is for the SAST. Yeah? And you can just simply attach the file with the which has a vulnerabilities inside, and it will show you. And I have that. I can possibly show you the demo booth. So
But
yes.
Veracode is better at it.
Yes, but Veracode. I mean, this is the raw. So that was my own.
Thanks, Nilesh. Thanks, John.
Okay.
Definitely insightful.
Thank you.
Thank you all.